Hi students, in this class we are discussing the previous year questions and other most important questions of the chapter light. Okay, so the first question is, in the given figure it shows a 60, 30 and 90 degree glass prism having critical angle 42. Okay, the critical angle for the given prism is 42. Copy the diagram until the incident ray AB emerges out. Okay, and we have to make the necessary angles wherever required. So let's check the diagram. So this is the answer. Since the incident ray is normal to the given surface, it straight away goes and make incidence at the given surface. Okay. Since the light travels from this surface to this surface, and the angle formed between the two surfaces is 30 degree. Here, at the point of incidence, let's say it is Q. At the point of incidence, the angle of incidence will be 30 degree. We already know that if the angle of incidence is less than critical angle, then refraction take place. Okay, refraction take place. So here the angle of incidence is 30 degree, which is less than the critical angle 42 degree. So here refraction of light take place, and here the light travels from a optically denser medium, that is glass, to an optically rarer medium. So when a light travels from an optically denser medium to a rarer medium, it bends away from normal. Okay, so here the light bends away from normal on emerging from the glass prism onto the air. Okay, I hope it is understood. We need to know the basic concepts. If angle of incidence is equal to critical angle, then the light ray passes through the surface or grazes through the surface, making an angle of refraction is equal to 90 degree. Okay, when angle of incidence I is less than critical angle, then refraction, the phenomenon of refraction, take place. If angle of incidence is greater than critical angle, then total internal reflection take place. If I is greater than critical angle, then TIR, total internal reflection, take place. Okay, so now let's discuss the next question. So moving on to the next question. Here the diagram shows two rays A and B. One is of orange color and the other is of blue color, which is incident on a air and glass medium. Okay, we have to copy and complete the path of the rays A and B until it emerges out, and how we need to compare the speed of the light rays in glass, and we need to check whether the two refracted rays are parallel or not. Okay, I hope you all are aware of the VIG. Okay, V I V G Y O and R. So here the red ray of light has a maximum speed in glass, while the violet has the minimum speed in glass. Okay, and moreover the red undergo minimum deviation and violet undergo maximum deviation. Okay, these are the 2 points which you need to keep in mind. Also, the critical angle for red color is the least and violet is the maximum. Okay, these are the things which you want to know in advance. So let's try copy and complete the path of the ray until it emerges out. Okay. So clearly we have already discussed that the speed of orange light is greater than the speed of blue color. Okay, speed of orange is greater than speed of blue color, so it bends less. Okay, the orange color will bend less, while the blue color having a speed lesser than the speed of orange will take comparatively more time. Also, it will bend maximum or greater towards the normal. Okay, so here in the diagram I have clearly indicated that the blue light undergo maximum bending, okay, while the orange light undergo minimum bending. So this is the path of completion of the rays A and B. A bends minimum towards the normal and B bends the maximum towards the normal. This is what I have included in the last page. Okay, the velocity of violet is the minimum and red is the maximum. Okay, but the wavelength of red is maximum and the wavelength of violet is minimum. Also, you need to know that the critical angle for red is minimum and the critical angle for violet is maximum. Since here the speed of orange is greater than the speed of blue, it will bend least towards the normal, while blue light will bend maximum towards the normal. Okay, so that is the first thing. The next question is, we have to compare the speed. How does the speed of these rays differ in glass? We have already discussed the speed of orange in glass is greater than speed of blue in glass. Okay, are the two refracted rays parallel? No, the refracted rays are not at all parallel. It is clearly evident from the diagram the refracted rays are not parallel because I have already told you the reason that the speed of orange is greater while the speed of blue is less. So orange bends less while blue bends maximum. Therefore, the two refracted rays are not at all parallel to each other. Okay. Now the next and the most important question. The diagram below shows a path of a blue ray through a prism. Okay, we need to calculate the critical angle, the measure of the angle of prism, and first of all let us calculate this too. Okay, here it is clearly indicated that the blue ray passes from the surface AB to AC. So at the point of contact on the surface AC, let me draw a normal. Okay, so this total angle is given to be 133 degree. So since I have drawn a normal, let me mark that this particular angle is going to be 90 degree and the total sum is 133. So how will I calculate this particular angle? This angle can be given by 133 degree minus the normal 90. Okay, so 133 minus 90 is nothing but which is 43 degree. Okay, here it is also evident that the light which has incident on the surface AC after refraction passes through the surface, which means that the angle of incidence at the surface AC will be equal to the critical angle. Okay, we have now calculated the angle of incidence at the surface AC, which is found to be 43 degree. Okay, so here the critical angle for the blue ray will be 43 degree. Okay, here the critical angle for the ray will be 43 degree. Once again I will explain what I have explained now. Here given the total angle measure is 133 degree. Okay, we know that the light after striking the surface AC grazes through the surface. That means when it passes through the surface, we know that the angle of refraction is 90 degree. So here it is 90 and this measurement will also be 90 degree. Moreover, the total angle measurement is 133. So how do we calculate this particular angle? This angle can be calculated by 133 minus 90, which will be equal to 43 degree. Okay, since the light ray grazes through the surface after refraction, okay, we can conclude that the angle of incidence at the surface AC will be equal to critical angle, because when the ray of light is incident at an angle equal to the critical angle, we already know that when a ray of light is incident at an angle I, which is equal to the critical angle, the ray of light after refraction will pass through the surface, forming an angle of refraction to be 90 degree. The same concept is applied here. So here the angle of the critical angle for the blue light will be 43 degree. Okay, critical angle will be 43 degree. Now we need to calculate the angle of prism. Here it is evident that this is 90 degree. Okay, this is 90 degree. We have already found that the critical angle of incidence, at the surface AC is 90 degree. Okay, angle of incidence at the surface AC is 90 degree. Not 90, 43 degree. Okay, it is found to be 43 degree. So this angle is 43. Okay, so how do we calculate this angle, this particular angle? The total angle measurement is 90 degree, out of which 43 has been dedicated to this part. So the balance, this angle will be 90 minus 43. Okay, 90 minus 43, which will be 47 degree. So the measurement of the angle at this particular surface, this particular angle will be 47 degree and this angle will be 90. So we need to calculate the angle of prism. We can use the angle sum property, which is 180 degree minus 90 plus 47, which will be equal to 43 degree. So the angle of the prism will be equal to 43 degree. Angle of prism will be equal to 43 degree. Okay. This is what I have indicated here. Since the total angle is 133, we know that this angle is 90. So correspondingly, this angle is also equal to 90. So the angle which is formed here, this particular angle will be 133 minus 90, which is equal to 43. So the critical angle will be 43. Why I have concluded that the critical angle is 43 degree? Because the ray after striking the surface AC grazes to the surface. Okay, we know that when the angle of incidence is equal to critical angle, the light ray after refraction passes to the surface. Okay, so here the critical angle will be 43, and using the angle sum property, I have calculated the angle of the prism which was found to be 43 degree. Now the next question is, which color should you replace the blue ray for the ray to undergo total internal reflection? We know that for TIR to happen, angle of incidence must be greater than critical angle. Okay, so we know that we already know that the VIBGYOR, from among the VIBGYOR, we know the violet has the maximum critical angle. So for total internal reflection to take place, we can replace this blue light with violet or indigo, which has maximum critical angle compared to the blue light. Okay. Now another question. the same questions in a similar, the same question but in different fashion. Okay, so here we have to calculate the angle of incidence at the surface AB, that is I, and what is the critical angle for the block BC. Okay, here in the diagram it is marked as I. We need to calculate I as well as a critical angle for the pair of glass block. Okay, so let's try to solve it. Okay, only one information has been given, which is this angle measurement is 132 degree. Okay, as in the previous question, we know that this particular angle is 90, so this angle will also be 90 degree. We know that the total sum of the angle is 132. So the angle measurement of this particular angle will be 132 minus 90, which will be equal to 42 degree. Okay, which will be equal to 42 degree. That means the angle of incidence at this particular surface is 42 degree. We know that when a ray of light is incident at an angle of incidence equal to critical angle, the light ray after refraction passes to the surface. Okay, since at this particular surface the angle of incidence is 42 and the ray after refraction passes through the surface, we can conclude that the critical angle for the glass is 42 degree. The critical angle is 42 degree. Okay, so now let's try to find out this angle of incidence. Since this angle is 42, this angle is also 42 because they are interior alternate angles. This is 42. Since this angle is 42, this will also be 42 because they are interior alternate angles. Okay, we know that the total measurement of this angle is 90 degree, out of which 42 was allotted to this particular portion. So this portion can be found out by subtracting 42 from 90, which is equal to 48 degree. Okay, so here this particular value will be 48 degree. This particular value will be 40 degree, and we need to calculate the value of I. By the law of reflection, we know that angle of I is equal to angle of R. Okay, so since this particular angle is 48, we can conclude that the angle of incidence I will also be equal to 48 degree. Okay, so here the angle of incidence of the surface is 48 and the critical angle is found to be 32 degree. Critical angle is found to be 32 degree. Okay. Now a question is asked, what happens to the critical angle when the temperature is increased? We know the relation that refractive index is equal to 1 divided by sin C. On cross multiplying, sin C is equal to 1 by refractive index, or C is equal to sin inverse of 1 by refractive index. We already know that the value of refractive index decreases with increase in temperature. Okay, since the value of refractive index decreases with increase in temperature, applying to this particular equation, we can conclude that when the value of refractive index decreases with increase in temperature, the value of critical angle increases. So with rise in temperature, the value of refractive index decreases, which will result in an increase in the critical angle. So when the temperature is increased, the critical angle in effect will increase. Okay, so moving on to the next question. Here it also shows a ray diagram, and the critical angle for the glass is 42. We have to complete the ray until it emerges out. Okay, let's try to solve it. So here the light ray is incident and this particular angle of 42 was given. Okay, this particular angle of 42 degree was given and the critical angle is observed to be 42 degree. Okay, so let's solve it. We know that this angle, the total measurement of this angle is 90 degree, out of which this is 42. So this particular angle will be 90 minus 42, which is equal to 48 degree. Okay, so the light ray makes an angle of incidence of 48 with the surface PQ. We know that the critical angle is 48, but the angle of incidence is the critical angle is 42, but the angle of incidence is 48, which is greater than the critical angle. We know that when the angle of incidence is greater than critical angle, total internal reflection takes place. Okay, so TIR takes place and the light ray bounces back at the same angle of incidence. Okay, so here since the light ray was incident at an angle of 48, it rebounds back with the same angle, that is 48 degree. So here it is 48 and here it becomes 48 by the principle of total internal reflection. Okay, so in a similar fashion, since this angle is 48, we can calculate this as 42, that is 90 minus 48. Okay, since these two lines are parallel and this is a transversal cutting it, since this angle is 42, we can conclude that the angle of incidence at the surface PS is equal to 42. The angle of incidence at the surface PS is equal to 42. Now this matches to the critical angle. Okay, critical angle is 42 and the angle of incidence at the surface PS is also 42. So what happens is that the ray of light passes to the surface, making an angle of refraction to be 90 degree. So ultimately the ray of light now passes through the surface after the final refraction through the lens. Okay, after the final refraction, the incident ray grazes through the surface or passes through the surface PS of the given glass block. Okay. Now the next question, here it shows a rectangular block ABCD and light source P is embedded within it. The angle of the particular angle is found to be 42. We have to complete the ray PQ until it emerges out. Okay, so we can make normal here. Since this is 42, this angle will be 48. Given that the critical angle is 42, and now it is clearly evident that the angle of incidence is greater than critical angle, so the light ray rebounds back at the same angle, 48 degree. Since this is 48, this angle will be 42. So if we draw a normal over this surface, this angle will also be equal to 42. Since the angle of incidence is equal to the critical angle, the light ray will pass to the surface BC. Okay, this is the explanation. So here it is given this angle to be 48. So sorry, 42. So this angle will be 90 minus 42, which is 48. Since critical angle is equal to 42 and the angle of incidence is equal to 48, total internal reflection take place and the light ray will rebound back at the same angle, which is 48. Since this angle is 48, this will be 42. Since now we know that these two lines are parallel and these two lines are parallel and this is a transversal cutting them, they form co-interior angles or interior alternate angles. So this is 42 and this is 42. So the angle of incidence at the surface CB is equal to 42, which is equal to the critical angle for the glass block. So the light ray after refraction finally passes to the surface BC. Okay, these are the questions which has been asked in the latest ICC question papers. All you need to know is the three basic concepts. If the angle of incidence is equal to critical angle, the light ray passes to the surface. If angle of incidence is less than critical angle, refraction take place. If angle of incidence is greater than critical angle, then total internal reflection take place and the light ray bounces back to the same medium with the same with the angle of reflection same as the angle of incidence. Okay, so try solving more questions from your textbook. If you have any doubt, do comment. So thank you and see you in your next video.